Hi everyone, my name is Nicolai, and I'm going to introduce myself a little later. I think let's start with the actual content, which you're here to watch. So quick questions in the beginning, just to, for my own personal record. Who's here who's having his project running on Java 8 in production? It's like everybody. Okay, that's what I expected. Now, who's running something before 8? Few people, yeah, a little more than I'm used to. Who's running something 9 or later? 9, 10, 11? Few people, okay. So you've done most of this, right? So let's see whether I can still give you some new information. So because what we're going to do is we're going to take an application that works in Java 8, and we're going to try to make it work in Java 11. This means that I'm mostly going to look at what things can fall apart. Actually, I'm exclusively looking at those things that can fall apart. So don't take this the wrong way. There's lots of reasons to do this, not just fighting with Maven and fighting with the Java compiler. There are reasons to do this. We're not going to look at them. We're just going to look at the challenges. Slides are online. The project that I'm showing here is online on GitHub as well, and you can do the stuff there yourself and fight your way through it. Now, I was asked to tell you that you have to rate me, but I also just heard that I think the app is broken, so only the 5 button works. So just trust me on that. Don't try the other ones. Also, it's hard to follow Venkat. Please make me better than Venkat. That's my only goal here today. Okay, let's start with a quick introduction to the module system. Once again, more questions. Who has ever seen a module info Java file in a blog post, in a video, in a presentation? Great. Who has ever written one? Very few people. Okay, good. So it makes sense to introduce this. So just very, very quickly, jarhell is bad. We all know that. So why is jarhell bad? Because the jar has we think artifact has properties that a jar doesn't actually have. And that's a problem. This mismatch is a problem. So jar doesn't have a name that the JVM cares about. The dependencies of one jar to another are unexpressed. You don't have a well-defined API, by which I mean everything that's public is public for everybody, not just within that jar. And there are no concepts of versions. And we kind of got used to this. We build a lot of tools around this, and we still occasionally get stuff like no class def found error if a dependency is missing. You cannot really well encapsulate stuff across jars, so maybe a developer in your project had a problem and they Googled and they found a solution which means relying on some Spring internals, and there's no way for the Spring guys to prevent that, and now you have a dependency on an internal API, which is never good. And also then the problem with version conflicts, if you're just dumping 5 versions of Guava on the class path, you're actually just rolling the dice to see what happens. And these are all consequences basically of jarhell. So enter modules, they want to fix this. The 3 basic properties that the jar does not have, a module will have, or that module has. It has a name, has explicit dependencies on other modules, and it can define its own API, meaning it can keep stuff just within the jar. Still doesn't have a concept of versions, so we're still going to face those problems. But we're going to see those problems earlier, ideally at launch time. We're going to get the information that something's not okay there. The goals of the module system evolved over time. By now, I would say these are the 2 most important goals: reliable configuration and store encapsulation. And we want to look at both of them very quickly. But before that, we have to see what a module actually is, what makes a module a module. And what makes a module is a source file module info Java that is then compiled into module info class, which is then added to the jar. And that's the only difference. It's still a jar, still contains classes, with bytecode. You can even have Java 8 bytecode in there and just the module info class compiled in Java 9. So that's the only difference between a jar and a modular jar. So what things do we have there? We have a couple of things going on there. First of all, module, it's a keyword. Java SQL is the module name here. So that's the actual Java SQL module. We're going to ignore what transitive means. It requires 2 other modules. It requires Java logging and Java XML. Those are the dependencies clearly expressed. It uses something, which is a service. We're not going to look into that. And then it exports packages. It's a little bit confusing at first, is that Java SQL down there is a package, Java XML up there is a module name, and Java SQL at the top is also a module name. But you'll get used to it. Let's quickly go through 2 things I just said: reliable configuration and how that works, and then store encapsulation. Reliable configuration builds on these requires clauses. And the idea here is that you express your dependencies, and the module system will make sure everything is you have a reasonable chance that the jars that you selected to launch your application can actually sustain the application. It will make sure that all modules that are required are actually present. That there cannot be any ambiguity, meaning you cannot have 2 jars both claiming that they have the same module. There can be no static dependency cycles, and finally no split packages. And whatever the hell that is, we're going to see later. That's the first goal. The module system can make sure that the configuration you want to launch with is reliable. The second one is strong encapsulation. It builds on these exports clauses. And what it does is it limits what you can actually use. So let's say you write some code that wants to use the result set. If that code is living within a module, you cannot just start using the result set. Result set has to fulfill three properties have to be fulfilled. The first one, result set has to be public. That's the old stuff, right? If you want to access code from a different package, it has to be public. But there are two new conditions. The first one is that Java SQL, the package, has to be exported by the owning module. In this case, the Java SQL module. That's the second one. And the third one is you actually have to read that module, which usually means you have to require that module. So you cannot accidentally start using stuff that is a transitive dependencies of yours, right? You're using Spring uses OK HTTP. As it is today, you can just start using OK HTTP without ever expressing a dependency on it. That's not a good situation to be in. So the module system makes sure that that would not happen. You can only use stuff that you directly depend on. And the big thing here is that I, as a module developer, can decide which packages to export. And if I don't export a package, all the stuff in there, even if it's public, remains visible only within, remains accessible only within the within that module. And that's cool because it means that as a library developer, as a framework developer, as a JDK developer, you can finally make sure that people are not using stuff that they're not supposed to use. But even as a developer of a larger application, that will help you. We have an application that has like 400 something jars. And I'm sure there are tons of situations in there where someone wrote some code and thought it's just going to be some class that I use in this context here. And then somebody else from a different project just started using it. Because, hey, it's so easy. There was no really good way to make the distinction between something that is public because you need it to be public, because you need it in the next package over, and something that is public because you want everybody to use it. And this is really important difference that the module system brings to the table. Now, what we see here is part of a module graph. This is, you can actually read it. Usually it's not that readable. So in the top, you see Java SE, which is a module referencing all the modules that fit into the Java standard edition. And then you have down there Java base, which contains such interesting stuff like class loader, object, string, Java util, all that kind of stuff that everybody needs. That's why everybody needs Java base all the time, why you don't even have to mention it. And then you see a bunch of other modules there. I'm not going to go into details. I just want to show you that how these dependencies are expressed is not only a figment of our imagination anymore. So this graph is not only what the JDK developers would like their dependencies to be. These are the actual dependencies as the module system understands them. And the same can be true for your application. When you modularize your application, then what you think the dependency structure is and what the JVM thinks the dependency structure is becomes the same. There are a couple other features. I'm just going to leave the slide here for a second. I'm not going to discuss them in detail. But there's lots more that the module system can do for you. Particularly services are interesting, which is not specific to the module system. You could have done that before, but it brings it more to the front. And then down there is JLing, which is a great way to create runtime images which contain just the stuff that you need. Tons of things to look into. I'm not going to do that now. What we're going to do now is not even create modules. What we're going to do now is we take something that already works on Java 8, and we're going to make it work on Java 11, as I said. So that means we're not creating our own modules. We're going to see in a minute how that works out. I just want to show you that the application actually does something. Let's ask Maven for the version. You can see that third line from the top. That we use Java 1.8 here. And then we can just Maven clean compile. And while that is going on, and I always make that joke, I need a Maven plugin that plays a jingle during the build. Now if people from the Maven team here, maybe that's a feature request. That would be great. OK, they're saying no. Now I built this. Let's actually execute it. That's not working as expected. That's not good. Wait a quick moment. That's not supposed to happen. It built quite quickly. I wonder, did it not copy the stuff into app? Yeah, that didn't work out. What did I do? Did I Maven clean install? That would have been better. Yes, thank you. That's the truth. So what it does here, it builds it's a multi-module Maven project, and in the end, it copies all that stuff into the app folder. So I don't have to, build the class path myself. Now I have a better chance of this working. Yes, thank you very much. So what does the application do? First of all, it lists class path content, maybe some requirement from operations, who knows. And then it fakes some data by, it pretends to ask some local services, maybe microservice network that you have running, and asks us, look, there's an alpha 1 service, is it still alive? And then apparently it was alive in 2/3 of the cases. So it basically pings these things and collects the data, and it does that once every second, which is why you can see the output moving in these steps, and also exposes an endpoint which contains the same information as in XML. It's very simple. It doesn't do a lot of stuff. It does nothing useful, actually. It's just meant as a demo. And what I did then is I created this, and then I put in as many problems as you can possibly face while moving from 8 to 11. At least the ones that are somewhat common. So this works on 8. Now let's move mentally. Now we move to 9 mentally. We want to make this work on 9. The first thing is, do we have to create modules? And the other is, no, we don't have to create modules at all. The modularized JDK and legacy jars, just regular jars, have to work together, because otherwise you would have to do a lot of work before even considering working on 9. You don't have to do that. For that to be able to work, there are 2 requirements. The first one is, by default, usually the one system wants everything to be a module, but on the other hand, a lot of stuff isn't yet a module, and how can we marry these 2 problems? How can we figure out a way to make this work? And the answer here is the unnamed module. So the module system wants everything to be a module, so what it does is it takes everything that's on the class path, all of those jars, all of those classes in there, and just puts them mentally into one module, which is the unnamed module. Let's turn to the 3 properties. It has no name. You know, it kind of makes sense since it's the unnamed module. It can read all other modules, which means it can see all the exported APIs of all the other modules, and exports all its packages, which makes sense. So all other code can look into the unnamed module and use everything in there that's public. And whatever shenanigans you did on the class path, with shadowing classes, for example, or having the same version 5 times, having the same dependency 5 times in different versions, all that kind of stuff can still function within the unnamed module. So the rules that the module system imposes usually work between modules, but they don't work between jars on the class path on purpose, so that the stuff we're used to doing that we didn't get rid of yet, like shadowing classes, for example, that we can still do that by having everything on the class path being in one module. So we're going to face a couple of situations that are related to the unnamed module later. Now let's turn to actually trying to do this on Java 9. The first thing is to know that even if you don't create modules, things will break, or will break. Things can break. It depends on your application whether they actually will, but things can break just by running on 9 or later. And we have a couple of things that we're going to see, and I'm going to first have a look at some, let's first try this out, and then we're going to face some of the challenges. The first thing is, how exactly do you want to move to 9? One option is to just raise, or to 11. We're going to go to 9, then 10, then 11. You're going to raise your minimum requirement, or do you say, no, actually we still want to stay on 8, we just want to try out 9, 10, 11. And between 8 and 11, that may not make so much sense. Maybe you really want to move to 11. That would be a good decision to make. But you could also say, particularly now with more releases coming up, maybe we want to build against upcoming releases without actually changing our baseline. And then it becomes important to just switch the version that you're building against somehow, like on the command line or within the configuration. So my goal is here to keep the Java 8 build running while doing Java 9, 10, 11 specific stuff. And the first thing I want to do is I want to run Maven on Java 9. And one way to do that is to go into maven rc, which is a file that lives in your home directory. And here you can set the path to whatever Java home, for example, you want to have. You can put other things in here as well, but let's just do this. So now I'm going to ask Maven which version it is. You can see it's 904, which is already vintage, since you can't really properly download it anymore. So that's a good thing. So now Maven is working on Java 9. What we also want to do is we want to have Java 9 specific configuration. For now, for example, you may want to set the Maven compiler target. So let's do that. Let's go into the parent pom here. I think that's already opened. Yes. Let's go into the parent pom here. And now I could just raise these settings here, source and target, to 9. But then again, it wouldn't stop working on Java 8, and I don't want that. I want it to continue working on 8. So I'm going to create a profile instead. I just copy-pasted that because I can never remember how to type it. If you don't know about profiles, you should really look into them. It's a pretty cool Maven feature that is exactly the right tool here to solve these problems. What we're basically doing is, in a profile, you can add additional configuration to your build. And if that profile is active, it will overwrite the rest of the configuration. So for example, what we can do here is we can create a profile, we call it Java 9+, and we're going to activate, it's going to auto-activate by itself as soon as it detects that the JDK is version 9 or higher. This is the open interval from 9 to whatever. So then in that case, the profile becomes active, and then you can add regular stuff here. For example, I could add the build tag here, and then, not like that though, add the build tag, and then I could add build-specific stuff. What I want to do though is set the Maven compiler release property to 9. What's release? Release is like setting source to 9, setting target to 9, and forcing the JDK to actually compile against the 9 API. All of these things in one Maven compiler release here. Okay, now we're set up. Now we're not only running on 9, we also want to compile against 9. So let's give that a try. As you can imagine, it's not going to work. Maven clean install. That jingle again. Maybe I should just come up with the jingle here. So what do we can see? So first we have a failure in the utils project, because every good Java project needs utils. Let's go there, and let's just repeat it here so we can see it more detailed, what exactly the problem is. And what we're seeing here is that a class base64 encoder from the package sunmisc wasn't found. So the first thing when you see this should be, wait, sunmisc? That's not a Java project. That's not a Java package I'm supposed to use. Everything that starts with sun is potentially an internal API, right? Well, not potentially. Everything that starts with sun is an internal API. So, and most of the stuff that you find in com.sun packages, which are not third-party dependencies. If you find third-party dependencies, then com.sun packages are fine, like reference implementations. But everything within the JDK that is com.sun is also, unless marked, is also considered internal API. And as I just said, this stuff is encapsulated by the module system. But to make life for us a little easier, if you just compile on 8 and run on 9, then at runtime this encapsulation is turned off by default, to give it a little bit more chance to actually make it work on Java 9. But I'm not doing that. I'm compiling against Java 9. And the Java 9 compiler will tell me, look, this is not something you're supposed to use. And then there are some critical APIs that might survive longer, or actually did survive longer, like sunmisc and safe. They're slowly whittled away, making into properly public APIs. And so I think the long-term goal here definitely is to have all the sun classes at some point being purely internal. So how can you find these things? You can do it the hard way and just have your build fail, or what you can do as well is you can use jdeps, which is a command line tool. You will find it since Java 8 in the bin directory of your JDK install. And it has a flag specifically for this use case, the JDK internals flag. So what I'm doing here is I'm telling a jdeps, let's start from the bottom there, scaffold hunter 263 jar. I'm telling it, analyze that jar. But not just that jar. Recursively look into its dependencies. And by the way, if you're looking for those dependencies, here's the class path. And the thing I want to know from you is, what about JDK internals? So we get output like this. Apparently, Bartek codec jar, whatever the hell that is, uses the JPEG codec class. And if you do this on your command line, you will actually see fully qualified class names, but that make the slides unreadable. So you get all the information you need there. Guava uses unsafe, and the scaffold hunter itself apparently uses the Windows combo box UI. So you can get this output, and you can clearly see what needs to be changed for this to be able to properly work on Java 9. That's not the only way, though, to do that. jdeps only analyzes bytecode. So if you use reflection, jdeps will not be able to detect that. So what you also have to do is to look into every call like class for name, or particularly the set accessible calls. Every set accessible true on something that comes from a JDK has a fair chance to fail, particularly if this is not an exported class. The unfortunate truth here is, while jdeps works great on your dependencies, you also have to do this to your dependencies, and there is really no automatic tool. So strictly speaking, you would have to manually check your dependencies, or you just trust your test coverage, and you're just going to run all the tests on 9, and then you may see them fail. Oh yeah, what do you do then? Sure, of course, the thing that if it's your code, you just fix your code. You find a way to not use an internal API. If it's a library or framework you're using, open an issue if there's not one there already. And finally, if you're using a project that is a little bit older, then you may consider just leaving that behind, just looking for an alternative that is still well maintained, that will fix these things for you over time. There's one solution that is really like the gap stop, like the last thing you wanna consider, and this is using command line flags. So with add exports, what you tell the module system is, okay, I know I'm not supposed to use that class, but please export that package anyway, so I can still use it. You can have add opens, which does the same for deep reflection, and generally there's an illegal access flag that you can look into to turn this knob up and down. So for example, what I did is I turn illegal access to deny. So even though Java 9 would let me run code against internal APIs, I don't want that to happen. I want that to fail so I can find those instances and root them out instead of them working silently for now. So all of that setup, that's surely what's going on here, right? I'm surely using an internal API. Well, yes, I'm using an internal API, but it's not just encapsulated. This stuff is gone. So what we can see here is that the problem is in the class utils. So let's go to the utils class. There we go. Base64 encoder and IntelliJ already switched. I think the profile is active here. The Maven profile is active. So I already switched the compiler level, and already IntelliJ shows me that this is not possible anymore. Because Base64 encoder and decoder, which are by far the most used, not by far, which are the most used classes and the most used internal APIs, by the way, even more than unsafe, they were just removed. And there's an alternative since a long time. And now let's see whether I can actually type this correctly. Base64, and then I think it's get encoder, and then encode get bytes, and there's still something missing. Let's see. What is that? I think you just don't have to unpack the bytes here anymore. Or do you? Let's see. Oh yeah, true. It's called encode to string. There you go. Okay. So some internal APIs, and that's the reason why they're considered internal, might actually just go away. And that's the reason why you don't want to use them, because nobody's like paying attention to keep them backwards compatible. At least not in the same strict sense as everything else. So that means you really have to look out for those internal APIs to make sure you stop using them before they're removed and everything just falls apart. So instead do that over time and use tools like JLink to find internal APIs, and use the tool called jdeps, which is right next to JLink in the bin folder, that you can use to find deprecations. Now let's go back to building this. That's good. Looks better. Oops, do you see that warning block there? Warning, an illegal refractive access operation has occurred. Illegal refractive access by blah, 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 blah. So this is the warning that you're getting when somebody uses reflection to break into JDK internals. This can happen as well. And there's several ways to deal with this. Let's start with the gap stop that I told you that you can always use, which are command line flags. Let's go back into the project. Now we're going to configure Maven surefire and tell it open that package to reflection. So we're going to do that by once again creating using a profile. I'm big on copy pasting, so let me do that. There's monitor utils here. That's the POM for that project. Let's go in here, put in that block. Don't need this though. What we're going to need now, and once again, I'm just going to type most of that in. Let me see. There we go. So this is the block that we need. We're configuring the build. Specifically, we're going to configure the Maven surefire plugin, and now we're going to configure it. And we do that by using the arc line thing, which appends command line arguments to the execution. And we're now going to use the flag illegal access. Illegal. I'm really good at making lots of typos, as you will observe. Illegal access deny. So what that does, let's just run that one now. What that one does, it denies these kinds of access, which is the reason why I usually put that into the parent POM. I just don't want to allow these access at all. I want them to fail like now. Now I get an actual error instead of a warning telling me that this didn't work out. What I can do now is I can have a look at this, and the underlying exception is an inaccessible object exception, unable to make this accessible, blah, blah, blah. Java base does not opens Java lang. And this is the solution, one solution that we can take. We can make it to open that. We can tell it, okay, add the opens directive. And this one takes first the module name, Java base, then the package name, Java lang, and then because we're in the unnamed module, remember that? We're going to open it to all unnamed modules. There can be several, but let's ignore that for a moment. Now we're advising the module system to not care about this encapsulation for this specific package. Now we can use deep reflection over it, and now the tests work without any warnings. Now what you gained by doing this is that you know specifically where a problem lies. Now you know, oh, we're using internal API here. We should work over time to reduce this, to remove this. And one way to remove this, which is really, for most situations, it's just the most straightforward solution. If you have any problem with the module system, the first thing you do is you just check if it's a dependency, and if yes, you just update that dependency. So that's something I'm going to do here. I showed you how to do this, but now I'm going to throw it away because we don't actually need it. What we can do instead is we can just update Mockito to a version that doesn't have this problem anymore. Let's see, there we go. Mockito is actually hard to find a solution, hard to find a version that had that problem, because Raphael Winterhalter, who's working on this, on Mockito and on ByteBuddy, is really good at keeping up to date. So if you just regular update your Mockito versions, you won't see problems like this. So once again, let's quickly build this. This should work now without any additional command line flags. So you will see these command line flags, and they are important, but they should be the last solution that you consider. Try stuff like updating, for example, or removing dependencies on these APIs. Try do that first. Okay, that works. Now we're going to install the entire thing. And while it runs into the next error, I'm going to show you on the slides what that will be. Those will be the Java EE modules. So in JDK, there's a ton of stuff that is not actually standard edition. Well, it's not there anymore, but it used to be there up until and including Java 10. You had stuff like the Java activation module, which contains the Devoxx activation package. Core bar was in there, Devoxx transaction, all that kind of stuff. And those were these 6 modules. I'm going to walk you through this, but I assume most of you will go from 8 to 11. So the solution I showed you now is not the solution that you will take. I just want to show you so you know how to approach similar problems in the future if they should come out. What I'm going to do here is I want to tackle the first part, which is they are deprecated for removal in Java 9. We're building on Java 9 here, remember? Deprecated means, well, for removal means they're going to go away, but it also means, in this case, that they will not be resolved by default. What that means is, we launched the JDK, all our stuff is in the unnamed module. It can use all the modules that are in the running system, but the Java EE modules are not in there by default. So what you will get, on purpose, is stuff like this, where it tells you that we had compilation failures here because the package Devoxx XML bind is not visible. It's not visible because it's not in the module graph, which is the next line. It's declared in the module Java XML bind, which is not in the module graph. Let me quickly point that out here. That makes more sense. There you go. So you do get a fairly good explanation of what's going on. And what we can do on Java 9 still is we can add that module. It's still in there, it's just not resolved by default. So now once again, we're doing the same trick as before. We're going to go to the right POM to steal the profile block. And this is which project again? Let's see, this is the REST project. Let's go to monitor REST, let's go to that POM. It's always the same kinds of steps. We're at the profile here, don't need that though. And now we're going to basically do the same thing we did before, but not with the surefire plugin. Instead, we're going to configure the compiler plugin. So we're having another build block here, plugins, plugin, and then we're going to tell the compiler plugin that we want to add arcs here. And nice that I have the Maven people here. Why is that not arcline? It's compiler arcs. So there are two different tags here to remember. The arc command line arguments are not attached in exactly the same way. I can use both. Oh, I can use arcline here? Yeah. See, it's awesome.
No, the other one. You can change arc into any value.
Okay. I'm going to keep it like this now. What we're doing now is we're adding that module to the resolution. Okay, let's go into the monitor REST thing. They never complain about stuff when the people who write that are present. That's not. Maybe I should take that away from this presentation. Let's see. This should work now. Oops, more mistakes. So I cannot find. We go here. I cannot find the symbol generated, which is in the Devoxx annotation package. Okay, so it's a little odd because it doesn't say from which module that comes. There's a reason for that, and we're going to see that in a minute. But for now, let's just repeat what we just did. Generate is from the Devoxx annotation package, and if we look at generated, for example, here, this is the IDE opened that class for me now, and then I can look up, for example, this is one way to look up where you're going to find that, in which module. This is already on 11, so I can't see it here. So you have to figure out where that comes from, this class. That might happen repeatedly. You find a package, you find a class, you don't exactly know which module it comes from. Head to the Java 9 or later Java doc, and wherever you go, it will not only list the package, it will also always list the module that something is in. So that's the way that you can find this out. But for now, I'm going to tell you that the module is Java XML WS annotation. So we need that as well. Let's dump that in here too. And now this is where things get out of hand a little bit. This is by far the most devious problem you're going to encounter, because we now get new compile errors for something else. We now get compile errors for non-null, the non-null annotation that is also in the Devoxx annotation package. Why? So why is it not found? Is it not? I mean, it's a dependency. It shouldn't be on the class path. It's easy to figure that out. We can ask Maven to give us full output of everything. And you will see the class path somewhere here. And now the JSR 305, it's also a challenge to find it, but I mostly succeed. Somebody sees it. Help me out. So there's the JSR 305 jar, which, Oh, there we go. See? Thank you very much. Down there. So the jar is on there, but if the jar is on there, then why is the class not visible? And that's called a split package. Let's do that next. So let's take a step back. Let's look at, not at the migration situation, let's look at the regular module system approach here. The idea is that a package should have a unique origin. So for every package, the module system wants to know which exact module it comes from. The formal way to do that is, that it's put into words, is no module must read the same package from two modules, but the actual implementation is much stricter. No two modules can contain the same package, whether it's exported or not. So you cannot have two proper modules containing, for example, the com or company something, a package. Now remember that packages are not hierarchical in Java, right? We tend to see them that way because that's how they play out on the file system with the folder structure, but it's not actually the case, right? So com foo bar is not a sub-package of com foo. These are two unrelated packages. So when I say they cannot split the package, I mean they cannot split the exact same package name. Right? So you can have com foo in one jar, in one module, and com foo bar in another. What you cannot have is com foo bar in both. This is called a split package if you have the same package twice. The thing is that the module system does not expose the unnamed module to all of these checks. Remember, because the unnamed module is supposed to be able to behave as chaotically as the class path did in the past, so it's not exposed to that check. So with Devoxx annotation, what happened here? Before we added the module that contained that package, the module system, or rather the class loader, would find the non-null class on the jar in the class path. Then we added the Devoxx annotation, Java annotation module, and now the module system knows, hey, wait a moment, that package is in that module over there. So when it looks for generated, it goes over to that module, looks into those packages and finds it. It's done. When it looks for non-null, it goes to the same module, looks into the same package, and doesn't find it there, and then goes nowhere else looking for it. So stuff that is on the class path, if it's in a split package, becomes invisible. Now, this is not a terribly common mistake. I only included it here because if it happens to you, it's really not intuitive what the actual problem is. That's why I'm showing you this. So if that ever happens, that you feel like, wait, why doesn't this compile, why doesn't this run? The class is clearly on the class path. If that class has a name that sounds like that package you might find that package somewhere else, like the Devoxx annotation package, then you may be in this situation. So for example, XML APIs project, which comes from Xerxes, I think, does that. There is a couple of JBoss modules which do this, but usually to Java E modules, so that's fine because they're phased out. And then JSR 305 splits the Devoxx annotation package, which might be the most notorious example here. You can use jdeps to find these. If you just run jdeps regularly, it will mention split packages basically at the top of whatever you do with it. So in this case, I just use a summary version to just give me as little information as possible. And then you get things like this. Devoxx annotation that's found twice, once in the Java runtime, that's what JRT means, in the Java XML WS annotation module, but also in the libs folder in the jar. So once again, jdeps is there to save you. It will tell you that these problems occur before they actually occur. So what can you do? That highly depends on what exact situation you're in. If this is just stuff that you later, when you modularize your own code, if this is just happening to your code, and that's highly likely, for example, for the application I talked about earlier, we have hundreds of jars. I'm sure we split a lot of packages. So if we start modularizing those jars, we will have to pull those apart. If that situation occurs, the first and easiest thing is just rename one of the packages, if it's just accident. If you want them to be in the same package, then you may need to merge these artifacts, either just the packages or the entire artifacts. You can always go back to just putting both artifacts on the class path, because remember, on the class path, this is within the class path, that is not a problem. The problem only occurs if it's from a class path to a module. If it's between two modules, then also the module system will tell you about it while it launches. It's just the specific situation, class path and module path, that behaves so hard in a way that's hard to debug. We're not in any of those situations, right? One of the modules we're using is not really under our control. It comes from the JDK. So what we can do instead is we can figure out the module that we're using, the jar that we're using, is that supposed to replace the entire module? Because this is a thing that can happen. Like we have one implementation in the JDK, but you have a different implementation on the class path, and you want to replace the JDK implementation, then use the upgrade module path for that. But we're not in that situation either. We just want to marry these two things, and that's where patch module comes in. It's also quite a hack. And I still want to show you because maybe once again I can get help here. Because the way that I figured out this would work is you go into the right project, which is this one, and then you add the patch module thingy. And now I'm going to walk you through what I'm doing here. So this is the argument. Patch module is a flag. And we're going to say, OK, take the Java XML WS annotation module, the one that I added in the line above this one, and then take all the content you find in the JSR 3 or 5 jar and dump it into that module. Treat it as if the classes in that jar were actually a part of that module. Now, how do I find the class path to that jar? This is the way I found to work. This is very, very uncomfortable. I didn't feel good doing this. If I would do this in real life, I would maybe find a way to include the jar in the repository, actually. So that would be part of version control. So I have a clear path to point to. I'm not making a recommendation to do this. Quite the opposite. I'm making the recommendation, try not to use patch module. It may be the only solution you have. That would be unfortunate. But otherwise, try to find a different solution. But with this, we should now be able to compile. Let's not just do this. Let's install the whole thing. Now we get this. Patching the system module blah is not allowed in combination with release. Remember when we put release here? I told you how awesome release is because you have the source and target. And at this, I don't know why release doesn't work with patch module. I'm sure it's not a technical reason, but just to keep things saner. But at this point, I was just giving up, and I didn't look this up. Why? I was like, okay, whatever. I was beaten into submission. I just do what you want me to do. So this should work now. Now we're done compiling. OK. So while we compile the entire thing, let's quickly go back to something by Java e-modules, just something I forgot that I want to point out. jdeps also gives you a list of modules that you depend on. So if you want to figure out whether you depend on a Java e-module, once again, jdeps is there. It will list all the modules, and then you can, on the right-hand side, you can compare that to the 6 modules that are on this list. OK. This split package is what we just did. Let's have a look. This works now. And now let's run it on Java. Well, if we do this, of course, it doesn't work because we used the Java 9 to compile it. Now I have to run it with Java 9, which on my machine, I did like this. And we immediately get a problem. Exception in thread main, class cast exception. The class loader's app class loader cannot be cast to Java net UL class loader. That's apparently in main. So let's have a look into main. And then if we look around, we'll see this method here, lock class path content. Remember in the beginning, you could see the class path content. And this is where the cast happens. So in the past, everybody knew that the class loader was always the URL class loader, right? That's the application class loader. You can always do this. Well, that's one of the things that we tend to do, which this is like changing the fact that the class loader is not actually URL class loader is not an incompatibility in the regular meaning of the word, because we were never promised it would be a URL class loader. We just kind of got used to and just did that cast anyway. This is something that can happen, and if this happens to you or to your dependency, then you have to figure out what exactly am I doing here and what would be a good replacement. In this case, I'm just analyzing the class path. I just give me the class loader, and then the class loader has a method called getURLs. I'm just going to get those URLs, and I'm going to stream over them and map and collect them and put this nice output there. So this specific use case is comparatively easy to replace because there's a system property for seeing what's on the class path. That would be this one here, java.classpath, and then I split on the colon, which is not good because this is not working across operating systems, but it's simpler now. So now I get an array of the class path entries, and then I can just use array stream class path. There you go. We don't need this anymore, and the rest should now work. So now, unfortunately, we have to build the thing again. While we do that, let's have a quick look at a couple of slides. I want to go through some other small things that changed. The JDK and JRE have a slightly different folder layout. So if you are actually rummaging around in those folders, once saw code that tried to figure out, it wants to compile code, so it wants to figure out whether Java C is in the bin directory. So it knew what exactly the folder structure was, and then was even guessing, hey, maybe if I'm running it as a JRE, but if my JRE is part of the JDK, I can walk some folders up and then have a look at that bin folder there. So that kind of stuff, that code, specific code will not work, but you can of course update it if you have to. So JDK and JRE have a new layout. All the internal jars are gone, RTjar, toolstar, they're not there anymore. If something depends on that, it would break. The JDK replaced the way that it stores code. It doesn't store the JDK code in a jar anymore because a jar is essentially just a zip and there's really no good way to evolve it. So the idea was, okay, we have JMods instead. A JMod is a new format for Java modules, and you will find a folder in your JDK where you find a JMod for each individual module. And this format is not standardized on purpose. There's a tool called JMod which you can use to look into these files and get stuff out and put stuff in. But the format itself is not standardized with the goal to make it more easy to aggressively evolve it instead of having to rely on a standard like zip. And then the next one you see there, application class loader is no longer URL class loader. We just ran into that. And as I said there, what we want to do is want to look at the class path and analyze it. That's fine. If you want to append something to the class path, which I occasionally see, right? I take a URL class loader and I add stuff to the class path because I want to add something like a plugin maybe. That's not going to work in Java 9 or later anymore. The class path is basically immutable. What you would have to do instead is create a new class loader that references the old one. And finally, the runtime image content has new URL schema. You saw it earlier with the JRT:/, that's new. All the APIs have, of course, been updated, but if you handcraft these URLs to resources, for example, then that might fail as well. So, of course, if you want to fix that, you look for code that does something JDK, JRE folder. You have a look at those URLs, whether they're handcrafted, and you can just search for casts to URL class loader. That's fairly simple, just a full text search for URL class loader, basically, and you're there. How we get here, let's see. We've built this now. Again, let's execute the thing. So part of this worked. We get the class path content out. But then when we want to use JAXB exception in this case, we get a no class def found error because Java XML bind, oh yeah, remember Java XML bind, that wasn't that Java E module that we had to add explicitly. Usually when you add something at compile time and or at runtime, you usually need to add the exact same flags at runtime as well when you want to execute the stuff. So that's something we have to do here. We have to actually tell the module system that we want to add the module at modules Java XML bind. That should work now. Let's see. Yes. Usually I would also have to repeat add the module Java XML WS annotation. I would also have to patch the module. All of those would usually have to edit. I don't have to do that here because in this specific use case, we're just dealing with annotations that are not evaluated at runtime. So that's why I don't have to. But usually you would have to do that as well. So if you work on a library or framework and you have a problem and you decide to fix it with a command line flag, that means that now all your users have to apply all of these command line flags during tests and runtime. So that would actually put a burden on your users, which I think is good because it gives a high incentive to library developers to not do this kind of stuff and instead try to find a proper solution for the problem. Okay, I got 5 minutes left. I really quickly want to see how far I can get with more Java versions, because the next ones are comparatively simple. First, staying on Java 9, if you're using any of this, compact profiles, extension mechanism, blah, 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 all of that is gone. Replacement for many of these is just the upgrade module path. And for compact profiles, you would just use JLink to create the runtime that you need. So these are obsolete and removed. And there are a few more things, and there are a bunch of links here to stuff that you can read. One of the last ones, interesting as well, the version string changed, which has nothing to do with the module system, just a change that was made. And of course, tools break. In this specific case, log4j, for example, tries to guess the Java version, and it fails on Java 9 because of that. My general advice is look out for internal APIs, because that's a common case. Look out for split packages. That's not a common case, but if it happens to you, it's fairly hard to find, so keep that in mind. And then deal with Java E modules as well. Those are the big things that are most likely to happen. What you should do is you should try to get your code in shape. If you have a large application and you cannot do this entire migration in one piece, don't worry, we didn't do that either. What we did is we just created, I worked all the time on master, so I never created a branch for this migration to avoid conflicts and to avoid getting out of sync. I use profiles to build to configure the builds in a way that it would work on Java 9. Much of that work, for example, has been updating dependencies. That's something that, of course, also works on your Java 8 build. So try to get your code in shape and try to do it as part of the regular build, so that the entire changes you make are built on the Java version that you support, but then also have a separate build that builds on Java 9. And if that doesn't work for all the modules in your code base, then don't worry, just pick a couple of them. Just try to start, whenever you have done something that works, make sure that it's checked by CI. Then if you're using any of anything that's suspicious, any IDEs and build tools are always suspicious, but also stuff that anything that promises high performance, anything that does something with mocking and bytecode, all of those things are potentially suspicious. So if you're looking at this, consider that you have to update them most likely, and that's just the overall recommendation. Just update all the things. If you do that, then you're most likely to evade problems. So if you consider upgrading to Java 9, but you didn't do it, or to 11 maybe, and you didn't start with that yet, a good preparation would be to just update all your dependencies. I know it's easy to say, and it's not always easy to do, but that would be the best preparation they can do. Maybe you are very likely to evade problems that you didn't even know you had just by updating. Otherwise, just download Java and just try it. Just do what I did. Just give it a try. Just run the build, see what fails. Okay, let's quickly go to Java 10. First of all, I do this trick again. So update here to Java 10. Maven-v should now tell me that I'm running on 10, right? Maven clean install. Now actually, I'm actually still building against 9, right? What I would also have to do is go into my POM, and now this is not Java 9 Plus anymore. I just want to have this profile for Java 9. And I want to just activate it on 9 and on 10. Oh, sorry, that's not good. Just the profile. There we go. I would create a new one here for 10. And in this specific case, I think I don't even have to do anything at all. Oh, I got a test failure. Oh, yeah, that's true. So what's happening here is that, once again, I told you earlier that SunMISC unsafe is slowly being evolved. This is another reason that, based on that, again, Mockito fails. And once again, I provoked this error, basically, by using an old version of Mockito. So once again, if we would have used the current version, I would not have seen this problem here. So a thing that once again, everything that depends on bytecodes, we will have to update that much more often than in the past. I just want to show you one thing that also plays a role there, and that's the ASM dependency of the Maven compiler plugin. Now let's keep it like this. Let's do this up here in the parent POM. So what you may have to do occasionally when you're building against early access builds or when you're doing these migrations rather early could be that you are on the current version of the plugin, of the Maven compiler plugin, but it's not yet updated with the updated ASM version. So you occasionally have to do that manually. So that's a general thing that you would also have to apply more frequently than in the past. Figuring out, oh, I'm using this version of Spring, and it's generally working fine, but just that one small thing it uses does not work on my Java version. So you just have to know, and if you're not using Maven, you have to figure out how to do it in Gradle or whatever else you use. You have to find out another way just to update that specific transitive dependency. So these kind of skills will come in very handy. But I've accidentally spent a lot of time with Maven during these migrations. I didn't consider it in the beginning. I thought I would be focusing on the module system, but I'm mostly more often focusing on how to get the stuff that I want to do, how to get the solutions into the build tool. Okay, I'm not going to continue further because time's up. I just want to say that in general, there's nothing much to do on Java 10. You just have some more deprecated methods and the bytecode level increased. That's why we have to update ASM. Then on Java 11, same thing, no big changes. The only thing is that now the deprecated Java E modules were actually removed, replaced them with a third-party dependency. And they should be great. There's a link there to a Stack Overflow question that I asked, where I found one replacement for each of the modules. So I have a starting point there. Some of them have more than one implementation, but so just so you know how to start out. Okay, once again, you have to rate me when I'm done, and also now done. I'm Nicolai, as I said earlier. I have a blog, I'm on YouTube, I have a Twitter account. I also wrote a book about the module system. And finally, if you need advice on doing your own migrations or in-house trainings, you can always reach out to me. If you have any questions about this, I'm not going to keep you longer now. If you have any questions about this, just come up to me now. I'm at the conference for the rest of the day. If you see me, just chat with me if you're interested in anything. And thank you very much for listening.